So, hello everyone. In the previous video, we spoke about how the peak to average power ratio can be battery vampire, right? So, it's all about if at all your signal is having a pattern something like this where there are occasional peak values that are occurring that are very higher than the average power, then your power amplifier needs to be unnecessarily biased, consuming higher voltages and higher currents, and thereby leading to inefficiency and battery consumption. And you can see here the formula for the peak to average ratio is given by the maximum power divided by the average power, right? The maximum divided by the average power. And a logical solution to this, as we concluded in the previous class, would be to clip them off, right? That was one of the, there are several methods. We are not going deep into it. Clipping is a very trivial method where you simply clip them off. But these kind of methods, or all those methods, whichever other methods are there, they usually come with issues, something like large side information, consuming much more bandwidth, or spectral regrowth, sudden termination, causing the width in the spectrum, causing other issues. Okay, so that is why a logical solution to this is given in LTE in the form of a single carrier frequency domain equalization. Okay, so what is the proposal here in LTE, that is 4G, is a transmitter at a downlink, that is from tower to the phone. They suggest OFDM based system, which contains an F50 action at the transmitter, that is at the tower, and IF50 at the transmitter and F50 at the receiver. Whereas you can see the SC-FDE block is something similar but much more different. What is done here is they take the data as usual, serial data, simply add a cyclic prefix and pass it through the channel where the circular convolution happens. Sorry, the linear convolution happens. But since you have added a cyclic prefix and then later you remove it, the linear convolution gives an impact, the effect that of a, it fakes that of a circular convolution. Okay, so that is why once you have that ready, next thing is you convert the data from serial to parallel, then you apply fast Fourier transform. Now applying fast Fourier transforms converts the circular convolution into multiplication. Then having estimated the channel, you do the frequency domain equalization as given in the title, frequency domain equalization. Then afterwards, since you had taken an F50 in the beginning, you apply an IF50 and you recover the original signal. Okay, so how is this different from OFDM? As you can see, the IF50 action at the transmitter now has been moved to the receiver only. So earlier the transmitter had an IF50 action, receiver had an F50 action. Here, the receiver itself will have first an F50, which will help you do the frequency domain equalization, and again you convert the data back to time domain. Okay, that is single carrier frequency domain equalization. And now what advantage do we have here, by the way? So the advantage what we have here in this particular scheme is while doing the transmission, SC-FDA transmission, the signal does not have as high PAPR as that of its OFDM counterpart. I hope you remember the reason for high PAPR in case of OFDM was due to applying the F50. Okay, it was due to applying the F50, and now we will not have any such issues. Okay, now we will not have any such issues. Okay, so that is why this particular method is going to have low PAPR, about 3 to 4 dB lesser compared to OFDM. Okay, but having added CP, it allows you to do frequency domain equalization, which is another feature of OFDM, right? This also allows you to do frequency domain equalization. Okay, so OFDM lets you do frequency domain equalization, and also OFDM allows you to tackle fading. Okay, whereas SC-FDMA allows you to do frequency domain equalization, and SC-FDMA allows you to have a transmission which is having low PAPR. So, each has its own advantage and disadvantage. Each has its own advantage and disadvantage. Okay. Now, let us see what are the benefits. So, SC-FD has low complexity even for severe multipath channels, excellent bit error rate, performance close to theoretical bounds, decoupling of ISI from other types of interference. Okay, now I'm not into these differences. This one is important for me. By utilizing single carrier transmission, the peak to average ratio is reduced significantly by several dB relative to multi-carrier OFDM, that is OFDM. Okay, so here is the frequency domain equalization thing of action of SC-FDE, right? As I told you, since you had the cyclic prefix, that is why we get to write the circular convolution here. Even though what happened in the channel is linear convolution, then there was certain noise. And then afterwards, since the channels, all channels, now that you applied an FFT, IFFT, by the way, not at the transmitter, but at the receiver, again, all the channels have become very, very narrow, right? All the channels have become very, very narrow. And so you get to do the frequency domain equalization. Okay, so that's SC-FDE. Okay, so SC-FDE performance versus OFDM. Let us see what is the difference, by the way, between OFDM and SC-FDM. Let me take you to the textbook. Okay, let me take you to the textbook fundamentals of LTE and see what's the author's take on this. So here we are. What is the difference, by the way, SC-FDE versus OFDM? Well, one thing author wants to point out here, is in SC-FDE, the frequency domain equalization does not depend on the operate on the data symbols themselves, but rather than on the frequency domain dual of the data symbols. Remember, when we saw this particular diagram here, you can see whenever you did the frequency domain equalization here, whatever equalization that happened here in case of OFDM, this was not on the frequency domain. This was equalization, fine, but then it started from here on, okay, because here you converted the data from linear convolution to circular convolution, then you took an FFT, but actually the data is an IFFT. Here entirely data was in frequency domain, but once you did the FFT, it's once again the time. Then you applied the equalization. Whereas here you can see the data is in time domain. Now that you apply a Fourier transform, now the data is in frequency domain. Then you apply the equalization. Then you convert it in the time domain, back to time domain, okay, after applying IFFT. So what change does that make? Well, as per author, it says that the whole noise, whatever that was there after applying the IFFT operation, is spread all over the data symbols, okay, all over the data symbols. Well, that is a difference. Author says it does not make author goes to say that in most cases the bit error rate or SNR performance difference is negligible, seems okay. So that also is a comment, but anyway, it's a difference, all right. It's a difference, all right. Other than that, what else is different? Other than that, what else is different? You can see here the second one is an obvious difference. SC has a lower complexity transmitter, higher complexity receiver compared to OFDM. In what way is that? Okay, so the thing is, in a cellular system, see, this is a very important thing, statement that's made. This in fact, okay. So the idea is usually in the base station, whatever you have. Okay, let me see if at all I can draw this. Okay, so here, say I have my a tower here, and then here is my mobile. So there are two things. There is a transmission here, from the tower to the mobile. Okay, they say this is my mobile, and then there is this is reception. Okay, now this one is called as downlink transmission. Okay, this is downlink transmission, and this is uplink transmission. Okay, this is uplink transmission. So usually at the tower we have OFDM. At the tower we have the OFDM transmission. Okay, and we have SC-FDMA reception. We have SC-FDMA reception. Okay, SC-FDE, okay, SC-FDE reception. So whereas here for the mobile we have SC-FDMA transmission. Here I have SC-FDE. I have SC-FDE transmitter, and I have an OFDM receiver. I have an OFDM receiver. So what's the difference, by the way? What's the difference? So as per the entire design, what happens? OFDM contains one FFT action, one IFFT action. So when the data is being transmitted from the mobile phone to the tower, you have to do one IFFT. You have to do one FFT. You can, right? Whether it's FFT or IFFT, the computation complexity is same. So there is for transmission, you need to do IFFT once. SC-FDMA transmission do not need you to do either FFT or IFFT. Now let us see the tower side. Now let us see what is there at the tower. For OFDM, you need to do 2 times, right? For OFDM transmission, you need to do one FFT operation, which is IFFT operation, right? Okay. For SC-FDE reception, because it's the transmission from the mobile, but reception at the tower, you need to perform one FFT and you need to perform an IFFT. So totally you can see you need to perform 3 FFT equivalent operations, 3 FFT IFFT operations at the tower, and at mobile there is only one operation. So here the power consumption is more. Now you can see the whole power consumption theory, the whole power consumption burden is pushed to the tower end, whereas your mobile consumes lesser power. That means now your mobile phone will last longer. The battery in your mobile is going to last longer. Okay, so this was the reason why. Because, and second thing is your SC-FDE has very low PAPR. Okay, so this is the second advantage. First is already they had an advantage of reduced PAPR, so that your phone battery, so the power amplifier of a phone is sort of efficiently used. Okay, so it's going to last longer. Second thing is, right, how complex is an FFT or IFFT option, right? N by 2 log n multiplications, n log n additions, right? It was a complex task, and this particular task also is being done mostly at the towers. So it should be easy, right? So this should be, wait a second. Okay. So this is one more advantage. Okay, this is one more difference, I should say. Okay, that is one more difference. Okay, so there is one more difference you can see as quoted here. Wait a second. What it says is another commonly cited disadvantage of SC-FDE. Advantage, that's an advantage of SCE. There is a disadvantage. Okay, SC-FDE has its share of disadvantages also. So apparently one of the disadvantage of SC-FDE is you cannot use it comfortably with MIMO technology, right? Remember we spoke about how using 2 antennas at transmitter and 1 antenna at receiver is going to give you certain advantage. Okay, that advantage is called as MIMO. And but this particular MIMO thing, it works better with OFDM, not with SC-FDE. Okay, it works better with OFDM, but not with SC-FDE. That is why there is a chance that, okay, so here you can see, usually at the towers, they have multiple antennas, whereas your phone will have a single antenna only. Okay, so that's the case usually. You might have seen there are so many reasons, but then your downlink speed will be much higher compared to your uplink speed due to all these reasons maybe. Okay, another thing they say is it's sort of tricky to insert all the pilots to do the channel estimation and synchronization by inserting the so-called, preamble. You know what is a preamble? Just when you're trying to, start the data transmission, a particular packet or a symbol, you put some known pattern. Okay, that's called as preamble. Then there is something called as pilots. Okay, which are used for training purposes. They say it's sort of tricky to insert all those pilots or preambles in SC-FDE. Well, there are ways to do it, but it's a disadvantage. You can't code for the time being. Then in non-compatibility with MIME, that's the second disadvantage which you can code. So the advantage of SC-FDE, well, having SC-FDE reduces the peak to average ratio problem. It's having very low peak to average ratio. It also lets you do the frequency domain equalization, and in cellular LTE system, they use this technique in an asymmetric manner where your transmitter, the downlink transmission, which is from tower to the phone, is having 3 FFT operations, whereas your mobile phone will be less loaded because it's going to have a single FFT operation. Okay, so that's that. And there is one more topic, right? So we'll conclude this with the complexity. Okay, the complexity factor, computational complexity advantage of OFDM and SC. So this is not a difference, but this is an advantage. What your 4G had over your 3G or 2G. 2G or 3G, there also we had the channel estimation. But then after having done the channel estimation, the only way to recover the original data was by equalization, and a typical equalizer is nothing but a kind of filtering action where every order of the filter is typically called as a tap. Okay, and the filtering is a MAC operation, right? Filtering x of k h of n minus k with a summation sign is a MAC operation, multiply, accumulate, and we know how complex they are, whereas OFDM is a FFT IFFT operation. Remember, we had this problem of circular convolution property. The circular convolution property is supposed to